So what I want to do in this part of the tutorial is talk about the next part of improving movement of our clown. And we're going to look at the data type called a vector2. And this is already partially coded. So if you already have this, that's great. If not, you follow along, start adding this. We're in the main class, and we added a vector2 called clown position, and that represents the current location of the clown. Clown velocity is going to represent how much we want to change it by every time we update. So the velocity could be 0, in which case it doesn't move. And what we'll do is we'll just add the velocity to its position. So if we need to increase we need to move its position, we're just going to add the velocity. You'll see in just a moment how that works out. So the two new data types are vector2s, and they store two values, an x and a y, and they store them as a floating point number. So as we go down here, let's look at the initialize code. I've also added, after we did our background rectangle and our clown rectangle, I've added here the position. We're going to put its x position at 200.0. Now the rectangle is there, so what we're going to do is we're just going to match this rectangle to its position. And this is initialized, so it happens at the very beginning of the game. And that's going to change over time, of course. But we have to give it a starting point, and that's why it's initial, because it means it's the initial starting point. So we're going to have an x of 200.0, and we add a little f because it's a floating point. It's a single precision floating point. And then the y is also single precision, so we put the .0f at the end. And then it's velocity. Now, the velocity here is, remember earlier we were saying clownrect.x plus equals 1. This is the same here. We're going to say the velocity is 1. If we keep applying this velocity, it's going to be going to the right 1 pixel at a time and down 1 pixel at a time to create a diagonal movement. Now, what we want to do is, let's look at the update logic. Notice, our clown position, we take the current position and we add its velocity to the position. Then we take our rectangle. Now remember, clown position has an x and a y, so does clown velocity. So if the clown position is 200 by 200, in other words, x is 200, y is 200, we add the velocity of 1 to each. Now it's going to be 201 and 201 after one loop. However, we need to change the rectangle. Now the rectangle's x and the rectangle's y is an integer. It's not a floating point. So what we have to do is what's called typecasting. Now, typecasting is not when Gary Busey acts like the insane guy in the movie. You know, it's actually taking a data type and changing it to another data type. And casting it means we're putting it in this mold here. We're saying this floating point is now going to be an int here. And we can do it for some data types, like we see here. So we update our clown rectangles, x and y. And then in our sprite batch, we draw it just like we did before. We don't have to change that at all. So the real change comes in adding the vectors and adding velocity to the position and then matching the rectangle's position to the clown position. So we run it to test it out. It should be going down and to the right when we run it. And that's going to bring us to our first problem, which is what happens when our poor clown gets off the stage. He's gone. How do we get him to move? Well, that, my friends, is what we're going to do next. Okay? So this is all updating of the position, right? So this I'll put here, update clown position. But before we need to do that, we're going to check for screen boundaries, for lack of a better word. Now we can call it whatever we want. But what we're going to do is we're going to say what happens if, for example, our clown position is greater than the width of the screen. What if it's greater than the height of the screen? What if it's less than the width of the screen or less than the height of the screen? We've got to check for all of that. So that's what we're going to do next. Okay, so let's check. Remember, we're checking, it's if, right? So if. Now, in Python, you don't have parentheses, but in C# and many other languages, whenever you do an if and you do a Boolean comparison, you got to put them in parentheses. So we're going to check the clown's position. If the clown position dot x, okay. Now we want to know we want to know the width of the screen. Now I know right now the width of the screen is 800 pixels, but you know what? What if I decide to change it later? I don't want to have to go through my code and look for all the hard-coded numbers. So I'm going to use a variable instead. And so there's a variable already built into our graphics objects that will tell us the width of the screen. So I'm going to put graphics dot, and it's graphics device dot viewport, that's our window, dot width. See that? So we're going to say if our clown position x is greater than the width of the screen, well, what do we want to do? Okay. So if our x is greater than the screen, we need to change the velocity of the x. But what do we do? What do we do? How are we going to change it? If we're going one direction and we need to go the absolute opposite direction, what do? We back up, right? We got to reverse. In order to reverse, if we were going 1 pixel per second or per loop in a positive direction, the way to go the opposite direction is to go in a negative direction. So the best way to change our velocity from positive to negative is what? What do we do to change a number from positive to negative? So all we have to do is multiply the x, so the velocity. So we do clown velocity dot x, and we're just going to put times equals -1. We're multiplying it by -1. So whatever number it was before, it's got to be the opposite now. And then let's go ahead and we were going to the right. Let's check for the clown position. Clown position dot y now. And let's talk about the height of the screen. If it's greater than graphics device dot viewport dot height. Okay? So basically we just want to return it, right? So now it's just the same thing only with y. Clown velocity dot y times equals -1. Now my velocity is positive on x, positive on y. So this is the best way to check on here. So let's just go ahead and run this and see if that works. And then we'll see our next problem. So we're heading down. We go off, but now we head back up. And now we're going to the right. And we just kind of go off the stage, but we come back, and now we've gone off the screen. Okay. So what we need to do is, if we're just going to be bouncing around, at this point, if it's less than 0, we're going to multiply by -1. And it doesn't matter whether it's x or y. So we've got a couple options here. We can just put a bunch of if statements, like so. Clown position dot x is less than 0. Okay. That's simple, right? It's the same thing we did before, clown velocity, excuse me. I'm just going to copy and paste that in. Okay? So it doesn't matter whether it's going negative or positive. We're just going to reverse it every time we get to one of the regions. So let's do the same thing for the clown position y. And we'll test it all out and make sure he's doing what he needs to do. Okay, we put it all in here, and now let's go ahead and run it. And make sure he bounces off the walls like clowns are wont to do. Make sure that works. I might have to speed up the video because that's really slow. Of course, hopefully you see there's a problem with our clown. and that he kind of goes off the stage for a little bit. We'll fix that in the next tutorial. But at this point, you can see once we get to the last edge, we now know that the clown bounces off all of the walls. That works. What I'm going to do is end with just showing you the code one more time as to how this all works. And then on a later update, I can show you how you could condense this into fewer lines of code.